Good morning, colleague. Actually, yesterday I tried my best, but unfortunately, it won't happen the way we had planned because the video I did was too large, so it seems it was not able to upload. So maybe for today, being 18th, I'm going to talk about the cosine rule. Then, after going to receive the body of our departed MP, I will come and later talk about the hyperbolic. So this morning, in the next few minutes, I want to talk about the cosine rule. So a cosine rule, you can be told, prove that or show that in cosine rule is just that a squared is equals to b squared plus c squared minus 2bc cos a. You can be said this is the cosine rule. Then you are being told prove that this a squared is equal to this one, or derive this formula. Sorry, they want you to derive this formula of the cosine rule. So the simplest way to derive this formula of cosine rule, just draw a triangle like this one. Then after drawing this triangle, now we are going to label the axis. This one like our A, this one is going to be our B, then this one our C. Then with the angles, we are going to use the capital letters A, B, and C. This capital A, B, and C. So this side will be opposite. Now will be small a. Then the side now, this side will be small a, this side will be small b, then this side will be small c. I think you can see clearly now. This side, for the angles, we are going to use the capital letters, but for the side, we are going to use the small letters. For example, when somebody asks you, what is the length of line AB? The length of line AB is just C. This is the side, is C. Line AC is B. Line BC is A. So from there, we can start to derive that cosine rule formula. When deriving that formula, we are going to bisect this triangle of ours into two parts. As you can see, I have formed two right angle triangle. This is our right angle triangle, this is our right angle triangle, which means this is our height. That is our height. Then we can see we have two hypotenuse, this hypotenuse, then this hypotenuse. So you have two angles. So let us assume this angle, this point to be point D. This one, I have said let us assume to be point D. Then this one, the length of AD now, A to D, let us say it is X. Then the length of DB, it will be C minus X. Because C is the total length of AB. But now we want DB, it will be C minus X. So from there, we can now try to derive using Pythagoras theorem now. We are going to use Pythagoras theorem. I'm going to use Pythagoras theorem. Using Pythagoras theorem, we shall say h squared. We will find this h squared now. H squared is equals to b squared minus x squared. That is for angle. That is for angle ACD. Angle ACD. So using Pythagoras theorem is equal to h squared is equal to b squared minus x squared. That would be our equation 1. Then equation 2 will be that is h squared. This one is our first angle, then this one is the second triangle. So the second triangle will be h squared is equals to a squared minus c minus x squared now. That is it. Then we come, so this one will be our second equation, but we come and expand this c minus x. C minus x is like c times minus x times c minus x. When you multiply, you will get c squared minus 2cx plus x squared. So we replace them here. So h squared is equal to a squared minus c squared minus 2cx plus x squared. Close our bracket. Now this minus is going to affect this bracket now, whereby now h squared will be s squared minus c squared, then this one plus 2cx, then minus x squared. This is now our equation 2. So from up to there, you can see h squared, which means we have 2h squared, which means these 2h squared are equal. It's like equation of a straight line. You're having 2y. Y is equal to this one, y is equal to this one, which means you equate those two equations. So which means we are going to equate this h, which means h squared is equal to h squared. So h squared, the first h will be h x squared minus, b squared minus x squared is equals to this one. Now the second equation is saying s squared minus c squared plus 2x, then minus x squared. This one is 2cx, the way it is now. So up to there, you can start working out. You can cancel this one and that one, and then will be b squared is equals to s squared minus c squared plus 2cx. So up to there, we are going to find the value of this x now, because in our cosine rule there is nowhere you have x. So finding this x is you go to your triangle now. You go back to your triangle. Then from there you can see where there is x. X is in the first triangle x, or in the second triangle. So let us use the shortest way in the first triangle where there is x direct. So from there you can use the cos. We want to find this value of x now. It will be cos a now. We shall take cos a, whereby cos SOHCAHTOA. Cos is equal to adjacent over hypotenuse. So we shall say cos a is equal to adjacent is x over hypotenuse, which is b. So times b, which means x is equals to b times b. So which means x is equals to b cos a. That is the value of x now, our x we have gotten now. So if we have the value of x, we come and replace this point at this point now, whereby our equation now will be b squared is equal to s squared minus c squared plus 2c, but the value of x is this one, c b cos a. That is how you derive that cosine rule. So if you want to remain the s squared, we want to write in the form s squared is equal to b squared plus c squared minus 2bc cos n. We shall just collect the like terms. We shall move this point to the other side. Shall move this one to the other side, whereby it shall be this. When it moves to the right hand side, it will be, or we can move this one. Whereby it shall be s squared is equals to, this one moves to the other side, so which means this one shall be negative s squared is equals to, this one moves the other side, which means it shall be minus b squared minus c squared plus 2bc cos a. You divide by negative 1. So our final answer shall be s squared is equals to b squared plus c squared minus 2bc cos a. Up to there, I know you have understood. If you have not understood, please ask and I will repeat. So up to there, I don't want to have a huge video like yesterday, so let me pause up to there and then I will continue with the hyperbolic. Thank you.